Okay. I didn't even see any of that. That was out of my peripheral class. Oh my god, I didn't see that. Alright. That was definitely not even in my visual. I just surfed your book like down that thing too.
You think the camera saw that one?
Oh, it is guaranteed.
You should put that one on your
I'm gonna
website.
definitely edit that out there.
No, you should put that on your
No,
website.
that's
funny.
What?
You have to put that in there.
Lights, please.
Dude, I actually did that right.
I'm not reading this.
The scanner did really screwed up. Alright. Okay, real quick. It still makes me laugh. Guess what the number one mistake was that I saw? The only
Drawing
real
line.
route. What?
Drawing a line.
Drawing a line. If you draw a line that connects the dots, I got it wrong because what you just did is drew every coordinate from -3 up to 3. You're not supposed to draw a line connecting. Okay, I warned people that it was more than one that did it. Now I'm not saying here, but I'm just saying overall. Now, the second thing, when you square a negative, -3 squared, what do you get? Positive. The negatives cancel.
That's what I'm trying to say.
So you take -3, you square it, you get a positive, and you add 2 to it, and I had somebody tell me that it's -11. Number one, you failed in 2 accounts. -3 squared is a -9, right? If that's what you thought, it's negative, right? And then when you add 2, you don't get 11, you would get -7, so way to fail twice. So, but that's your points right there, you can kind of see that. So, the graph looks terrible. Sorry, I can't photocopy that. That looks really bad. But does everyone see my dots?
Yeah.
If you missed a dot, I count it wrong. Somebody forgot to graph a couple of them. I count it wrong. Oh, all right. So there you go. 4 points. How I was graphing that, I was looking for: did you have the coordinate in the right spot? Did you at least plot? Did you draw a line connecting that type of thing? That's the things I was checking for. All right. Number 2. Some people didn't plug in the numbers. I put in letter A in there on purpose because I knew somebody would just do the first 2 numbers and go up. It's A. You had to keep going to see which one it actually was because I know that -3 plus 8 is 5, and people would go, oh, there it is. But it was actually later that it's 2 minus a negative makes positive because then 2 minus a -2 is 4. -1 or 2 minus -1 is 3. The 8 rule would have failed right there. So you would have seen that these 2 would have failed. I put it in there on purpose. See how many people are actually trying out the numbers. Next one, does your y2 hit the origin? No, it doesn't. It hits the y-axis at 0,2. That means it doesn't hit the origin. That's your x number, that's your y number. Which point does y2 cross the x-axis? 2, 0. Somebody told me 0,2, that's a coordinate for a y-axis. Lots of people did that, by the way. And then your x value for y1, y2, I find it funny that people were giving me coordinates like that. I put coordinate there. It asked for what x number. That's -1. I understand what you're going with. You knew which coordinate it was. It was just that they wanted the x. That made me up. I had to put it there because I kept seeing that. All right, moving on. 5. No, I severely abbreviated the answer here. I was looking at yours to see how you set it up, how you were simplifying it. If you just didn't complete, you missed all the points there, 6 points. If you at least went a few steps and went through. Oh, did I?
Yeah.
Did it come up with? Where is it? Oh, boo. All right. Let me go grab it. All right.
Okay, you grab that.
Oh, man. Where'd it go?
Oh, goodness.
Someone has the answers.
Oh.
Okay.
Yeah, I went on the back and it didn't photocopy.
So you didn't get anything for
I was too wondering, but I was like, oh, maybe.
Hey,
That's when you put it in your calculator. 3 times.
I wrote down 2,0, and I was like, that doesn't seem right. So then I switched it. Otherwise, I'd look at the whole first page right. I destroyed the piece by squared.
Yeah, you have to put it in parentheses, because it'll just add the negative, so if you do
You realize that's happened to me before. She might be saying that, so it saves the surprise.
Oh.
that's what I think is funny, you put it in there.
It's a great cover.
Jordan.
It's tricky. I just thought maybe
Huh?
there's like
It didn't stand. All right. All this works. On my computer.
Actually, let's see.
I would have just kept going. I would have even phased me.
It's a P&W. I'm not even. I'm not mad. I figured I didn't get anything.
I bet you would figure this wasn't.
I got like a charger and I got.
All right, is that the next
So I went
one?
from -1 to
Yeah.
All right, good. I didn't pay attention to what problem we're on. All right, number 3. Okay, you can actually see I was drawing lines in there. All right, functions domain. There was no break in the graph. You went from negative infinity up to positive infinity. You should not use brackets. You have to go least to greatest. I warned you of that. Range. We started at 0 and went up. And yes, it was at 0. There was a dot there. That's called an x-intercept, by the way. You start there and you work your way up. The x-intercept is -1, 0. That's the coordinate. So you could just tell me -1. That is the x-intercept, but it's -1, 0 as a coordinate. Now, here's the funny thing. A lot of people got that right. They said -1, 0. Right? It's the other x-intercept. But then you got to the back page. What was that, number 6? And people crap themselves like, Ward, what's an x-intercept? You never taught us that. You just did it right 2 seconds ago. How did you get it wrong later? You forgot something in the 10 minutes it took you between them? So, y-intercept, 0, 1. And the functional value, so I already got cut off a little bit. The functional value, let's keep going. All right, at -4, my answer was 3. You can actually see I drew the line there. At 3, my functional value was 4. So there you go. I think most people got those right, if you attempted. So, all right, the one thing I was looking for, do you have these in the right order? Like, some people were going like infinity to 0, that you can't write it that way. It's got to go small bit. It's going to left to right. All right, but yeah, so that made me laugh. This one, people were getting this right. They went to the back page number 6 and they just had a meltdown. They couldn't do it anymore. You just did it 2 minutes ago. All right, domain of this thing. Here's what it looks like. The first one, you're starting at 0 and working all the numbers that are less than 0. X is less than or equal to 0. So I'd start at 0, plug in -1, -2, -3, and I plug those numbers in, right? Because it says, if you have like a certain X number. So I plugged in 0, 0 times half is 0, plugged in -1, -1 times half is -half, plugged in a -2, -2 times half is -1, plugged in a -3, I got a -1.5 out on my calculator. So those are plots. 0, 0, -1, -half, -2, -1, and -3, -1.5. So there's my coordinates. I could have kept going. Notice I stopped here. It stopped at 0 and went that way, less than 0. So there's your line, right? And you had to plug in negatives because you had to use numbers less than 0. Now, the second one, when you plug in any number that x was greater than 0, your answer is always going to be 3. There's no numbers to plug in. You can't plug in a 1, you can't plug in a 2, you can't plug in a 3. There's no x to plug into. So your answer, and you actually see me in my table. It doesn't matter which number I pick, 0, 1, 2, 3, the answers are always 3. It was called a constant. I even said it out loud during your review. I'm like, if there's a constant there, just make sure you're drawing right. Because I wanted to see how many people understood what a constant meant. You're hitting 3, boom, level. It's not 3 over 1, that's slope, it's just 3. Every answer is 3. So you had an open circle at 0, and all the answers were 3, it was flat. Okay, so the range. Range going up, it went from -infinity up to 0, included 0, because that was a filled in dot. Then it had a break, and it went at 3. Why do you think on review day, I kept putting that problem on the board, where we had a constant. All right, moving on. State the interval where this thing is increasing or decreasing. It is increasing as I climb from left to right. I'm climbing the hill from -infinity up to 0. It doesn't have any spots where it decreases, but it does have a constant where I went from 0 to infinity. And 0 is not included because it was an open circle there. So parentheses, brackets in that first one. But I was looking for the numbers. Did you at least get the numbers? This thing does not have a relatives maximum end because there's no hilltops. It doesn't go from increasing to decreasing or decreasing to increasing. But it does have an absolute tallest point. What's the highest point on this graph? 3. It was level at 3. That's an absolute max. And yes, I know this is an open circle, but these are all filled in. So the height was 3. That's what I was looking for. I was looking for, did you at least have a 3 there? I kept having people tell me that the absolute minimum is -infinity. That's not a number, it's a direction, so it doesn't have a minimum. All right, next one. That's geometry. You recognize that one. Let's go to the next page. is not that one. This one, right? Okay. So number 5, I skipped a lot of steps. I was checking for, like, when I was looking at yours, did you set it up right? Did you simplify correctly? If you didn't, you lost a lot of points right off the bat. If you released something, you just kind of messed up a couple things, like a lot of people messed up a negative sign, or they forgot to plug the x plus h into like the second part. So when I do this problem, this first part right here, this part is the f of x plus h. That's this thing. So that's the x plus h is plugged into here. Wherever there's an x plus h is plugged in. Then you're going to subtract the original function. I'm subtracting the original thing I started with, and that's all over h. Now, I did the foiling in my head. That's foiling first, outer, and last. So here it is. I distributed the negative 5s. A lot of people forgot the negative, by the way, on that. So I distribute the negative 5s. I have the 8, and then I distribute the negative sign in the back. Boom, you can see what I'm doing there. Negative, positive, negative. I got cut off a little bit. Then you would add like terms. The x squares are gone, the 5x's are gone, the 8's are gone. Now, what was the rule I told you when you do differential quotients if you know you're doing it right? What should happen on the top?
All the non-h terms will cancel out.
Non-h terms will cancel. That's how you know you did it right. So on mine, all the non-h terms went away. So I'm left with this stuff. And then the last thing is to do is just divide everything by h. So there we go. So I got rid of the h on the 2x, got rid of one of the h's on the top, and got rid of the h off of the negative 5, and that's my answer. That's how you do it. Okay, questions on number 5. Now, again, that you should have been able to be able to plug stuff in. It doesn't matter which function I gave you. In fact, the formula is still on the boards over there. I even had it written down over there. I called it the first derivative instead of a differential quotient. All right, moving on. Number 6. This is the part people are like crapping themselves. It was this thing right here. They're like, Ward, I don't understand why x or something. Well, you did a number 4 earlier, or number 3. Okay, it's just a coordinate where you hit the x-axis. So the coordinate where you hit the x-axis is negative 2 comma 0. That's a coordinate. You did it earlier. Okay, so I have my coordinate. I'm going to find slope. So I subtract the y's on the top. 4 minus 0. 2 minus the negative 2. I think somebody told me on the test 4 minus 0 is 2. That was the only goofy answer I saw on that. So they were just going too fast. Alright, so I got slope of 1. I tried to make it kind of easy for the slope. Slope is 1. You plug that in. I just picked one of the 2 coordinates. You had 2 coordinates to pick from. To me, the 2, 4 looked easier than the negative 2, 0. So the x subtracting 2, y subtracting the 4, I simplified by distributing the 1 and then add the 4 across. I kind of warned you on this one that the numbers were going to be nice and clean. Number 7, on the other hand, was not. And I kind of warned you of that on practice yesterday that you were going to get maybe a weird fraction. And you did. Okay, questions on 6. I would say 6 and 7 were probably the ones that most people missed points on, just because of like they didn't understand an x-intercept, which boggles my mind, or number 7, you just didn't even go anywhere with the problem. So, on number 7, you had to graph the function, so you had graph this one, this thing, and then you had to also draw another one that passes through negative 2, 2, that is parallel to it. Parallel means like railroad tracks. I had people giving me perpendicular, I had people giving me one line where there's supposed to be 2, that type of thing. Okay, so I had to pass through negative 2, 2. I had to have the same slope as this line. This line, what you're looking at right there, is that thing, the thing I have highlighted. How I know that? I rearranged it. Right now, what form is that thing highlighted in?
Standard.
It's general. It's general. It looks like standard, but it's general because they have the 0 on one side. So you'd have to move the 7 over, move the 2x over, divide by the negative 3. So that's what you see me doing. Now that you're in slope-intercept form, from general, you just graph it. This is my y-intercept. It's negative 1 point, or negative 2.3 repeating. So negative 2.3 repeating. I would go from this spot, rise 2, run 3, rise 2, run 3, just do the same. Even though I'm in the middle of blocks, it still works. Draw the line, and my line has to be parallel to this thing, so it just has to rise 2, run 3, rise 2, run 3, rise 2, run 3. And you can see how I'm drawing. The problem is that that's what some people did. They drew really nice lines. I had a couple people that really did a nice job on that one. but you didn't see the directions above. It said come up with the equation for it as well. This line that's parallel to this given one, the one that I highlighted, this is the highlighted one. I did come up with that equation. So I know that I had to use the same slope to be parallels, 2 over 3. And then the coordinate I had to pass through is -2, 2. So x minus the -2, y minus the 2, distribute over, and I kind of warn you when you distribute, you just take this number times the top. So I get 4/3. Then I had to add the 2 across, and that's the ugly part. When you add a 2 to the other side, it's 2 over 1, you have to get common denominators, which is 3's. So if I put a 3 here, that's 6 over 3, that's 4 over 3, and you add, you get 10 over 3, which is 3.3 repeating, or 3 1/3. And that should actually justify my picture. If I go back up there, so that's rising 2, running 3, and my y-intercept should be 10/3, because that's in slope-intercept form. 10/3 is 3.3. That's about right. That's about right where my graph hit, 3.3 repeating. All right, questions, comments? Okay, I'm gonna take these back to mine. If you want to do a retake, that is your option. If you failed, you have to. I don't know, you have to do the percents on that one. Just make sure that you're gonna take time, you're gonna come in here sometime, either today after school or next week sometime in the morning. You have 1 week from today, you're gonna retake, but the retake has to be done by next Friday. You're not coming in Friday and going, oh, Lord, I'm gonna retake it today. No, you're not. It's done by Friday next week, because that's the end of the quarter, and I'm not gonna grade it Friday night at 10 at night. Not gonna happen. It's grading every test I did yesterday at 3 in the morning. I don't wanna do that again tonight. What you need right now is just notes. We're going to intro our next section. That's it. We're introing, nothing more than that. So have your notes out. I'll give you a little bit of time to get your notes.
That would have been about my average on the test yesterday, about 75. Like good old, 80, I had 70, I had 72, 73. Just think about it.
Okay, let me get rid of that. I do need a graph though. Give that back. Yeah. Okay, what we're going into on Monday for sure, what we're going to be starting, we're going to be graphing. But now we're going into not just linear equations, we're going into polynomials, curves, and we're going to go to every different view. On Monday, we're talking about the transformations. This is something that's a big part of this. If you really understand what a transformation is, how you can move a picture by just looking at the numbers that affect it, you can do really quick graphs. Like your graphs don't even have to be super accurate, but they'll be in almost the right location. There's only a couple different types of transformations. Now, this is going to seem a little weird. This transformation stuff, it's in chapter 1, even though we're done with chapter 1. It's in the last section of it. It's 1.6. So I always wait to do this section before we go into chapter 2 to draw these polynomials, because polynomials are tough. A lot of people don't like curves. Linear stuff is easy. You know where to start. You know how the slope works. It's just straightforward. But curves, you need to know these little shortcuts so I can easily draw something. So there's different types of transformations. The first one is called a translation. Now these are going to be in no particular order. I'm not telling you that this is the order you do it when you do a problem. We're going to go through that on Monday. But a translation, the key word there is, this is a slide. So when you look at a formula, you look at an equation, it slides it right or left, up and down. The picture doesn't actually orient differently. It doesn't flip over. It's just literally dragging to a new location. So like in geometry, we did some of these where I gave you a picture like this, like a right triangle. Again, I'm not gonna give you triangles. I'm gonna give you like an equation, like some weird curve. And we're gonna move it to a new location. So like we're gonna move it to the right 7 and up 4. So to the right 7 and up 4, right? And that'll be in a new spot. But the picture will look the same, it'll just be in a different location. How you do that, the easiest way to do it is just take every coordinate, every major dot, every what we call vertices, right? So every vertex, and you just go to the right 7, up 4 on each dot. So this dot right here, over to the right 7. 1, 2, 3, 4, 5, 6, 7, up 4. 1, 2, 3, 4. So it's gonna be right here. That's this dot just moved to there. Then you do the same for the next one. I'd go over 7, up 4. And then the next one, over 7, up 4.
One down.
One down, right there. There you go. That's what you're doing. But I know that's like a rough intro, right? What we need to look at is how does that affect the formula? Because obviously we're not gonna have pictures like triangles. We're gonna have an equation, like a formula. So what does that look like to a formula? How would I immediately plug something in and it would just do that to the graph? That's what we're gonna look at. We will need your Chromebook. Does that make sense? We're gonna look at some technology because it's easier than drawing by hand. Hand takes a long time. But I want you to get a sense for where this thing's going and how to quickly do it. Make sense? And I'll give you some random stuff that we can do. Hopefully this will make sense. I'll try to show you the shortest, easiest ways to do it for me, how I think of it. Okay? All right, next, the second one. Second one, in no particular order, is called a reflection. A reflection is when you take a picture, you flip it over the x-axis or the y-axis, wherever it sits. So there's two types. There's y-axis and x-axis. And again, the whole point of Monday will be looking at how do you do it in a formula? Like how do I take an equation and magically just flip everything so that it goes to the opposite side, right? Because if I do this triangle, let's say I went back to my original triangle, and I wanted to flip it across the x-axis. So imagine that there's a mirror right here, and I want to go across the x-axis as a reflection. It would just be flipped over. It would be here, here, and here. Now, how I know that, why it's going to go there, is because the spacing has to be the same. So if it's one space from the x-axis, it's one space above it. If this one is 4 spaces, then it's 4 going this way. If it's 4 this way, it's 4 that way. And it's literally, I just think of like a turn in a book. You're just flipping a page and it's going to go the opposite direction. I could go the other way. I could go across the y-axis. I could go this direction. I could reflect it this way, across the y. But again, what we're going to look at is how do you do it in a formula? How do I take like some random equation that has some weird curve to it and immediately reflect it? What would that look like? So we're going to look at quick drawings. We're going to look at, can you just draw this really fast? Do you know what would happen? What would it look like? So there's going to be lots of little things. We'll try some different problems out. Okay, now do you see the clear difference there when you reflect it versus translate? Translate, you're just sliding. The picture should look the same. My triangle never changed. But when you reflect it, it's now facing a different direction. It actually looks like it changed. The third one is one of the most challenging. This is the one that we probably will have to take more than just Monday to work on. This is called the dilation. The root word there is to dilate. To dilate is to grow or shrink. So there's the growth or shrink, and there's 2 different directions. You could do vertical dilation, which shrinks it vertically, so it compresses it or stretches it vertically. And then there's the horizontal, where it can stretch it vertically and horizontally that way. So, so vertical versus horizontal. when there's a simple formula that we have for dilations that we can use, dilations sometimes do affect how far from that origin you are as well. So there's, in geometry, what you have to worry about if you're gonna multiply by 2, this picture is gonna get bigger, but it's also gonna get twice as far away. Sometimes that happens. So dilations actually move objects, so it looks like it's been translated, but it's bigger because of the way the dilation happened. I'm gonna try to do I think on Monday, we're gonna try to do look at the easiest way possible to do it, and then we'll show you the formula maybe on Tuesday for it. Because I wanna get to the formulas. How can you look at the formula and go, okay, they definitely dilated this thing. And how do you know where it's going? And then one of the most challenging the next one I'm gonna show you is a rotational thing. There is a formula for it. I will probably never ask you to do this on a test, but the last one, number 4, is a rotation. I'll never ask you to do the formula for the rotation. I'll have you just do the coordinates for it. So there's there's 2 types of rotations that we do in this class for pre-calc. We rotate 90 degrees, counter or clockwise, doesn't really matter. And then there's a 180 degree rotation. So there's 2. We just do it for coordinates. I'm not gonna show you the formula. The formula can get really messy. There is different types of rotations. You can rotate by 40 degrees, 30 degrees. There's different things you can do with those formulas, but we're gonna stick with easy ones. Questions with what we're gonna do on Monday. Now, I'm gonna warn you right now, I think in your class, I think there's gonna be a couple visitors that are coming in that day. They're not watching you guys, they're actually watching the lesson we're doing that day, like the style, because we're looking around and use technology and stuff, so just be kind of ready to go. Don't be thrown off. They're gonna probably participate, so it's part of being a model teacher, right? Some visitors, so. All right, questions though. All right, we're done. So there you go. Done for the day. I'm gonna keep it nice and light, nice and easy.